This video will be an introduction to rational expressions. A rational number is a number that can be written as a fraction. So a rational expression are expressions written as fractions. Now, there's a couple big rules when it comes to fractions. First off, whenever you have a fraction as your answer, you're going to make sure to reduce your answer. And we're going to practice reducing rational expressions today. Also, when it comes to fractions, let's remember that the bottom of a fraction cannot be 0. We're going to see some examples of those questions first and talk about how those are going to impact some things later. Let's look at example 1. The directions say state the restrictions of the variable. What those directions are really saying in more plain English is what can x not be? Now remember, the top of the fraction can be anything, but the bottom of the fraction cannot be 0. So this up here we're not so worried about. It can be whatever it wants. But this can create some issues that we have to be aware of. This bottom of the fraction, whatever I put in here for x and in here for x, cannot make this turn into a 0. So our job is to figure out what would be the problematic x's. So what we're going to do is state that the bottom of the fraction, 7x squared minus 5x, cannot be 0. And then we're going to solve this just like you would an equal sign equation. Since we have an x squared, this is going to be one of those where we set it not equal, in this case, to 0, and then factor and set each of the factors equal to 0. So it's already set equal, or in this case, not equal to 0. So we're ready to factor. I see a GCF, so let's pull that out. And then I don't have any more x squared, so I think we're ready to go ahead and set each of our factors equal to 0, or in this case, not equal to 0. Now this first one's already done. We get our first answer right here. X cannot be 0. Let's go ahead and move some things around on the other side. I'm going to add the 5 over. And then divide by 7. Don't panic, you're going to get a weird fraction. It's okay, it's just 5 over 7. And here's our other answer. Now what we're saying is if you put 0 back in here for x and simplify, it would make all of this 0, and that's a problem. If you took this 5 over 7 and put it in here for x, it would simplify this whole bottom to 0, and that would be a problem. This is going to come up later when we see these expressions inside of equations, because we're going to be looking for what x can be, but before we do that, we first have to talk about what x cannot be. Let's look at example 2. So up top, I've got x squared minus 16, and on the bottom, I have this little 12. What are the restrictions on the variable? Now remember, restrictions on the variable is saying, what can x not be? Well, we don't care about the top. We're only worried about the bottom because the bottom of a fraction can't be 0. So in this case, the bottom of my fraction is 12. So 12 cannot equal 0. Well, I think we all know that 12 does not equal 0. There is no x that when you put it in here is going to change the fact that the bottom of the fraction is not 0. It's 12. The only variables I have are up top, so that's not going to matter. It's not going to cause a problem. So for this one, because there's no x on the bottom, we have no restrictions. Anytime you don't have an x on the bottom, you don't have restrictions, because you can put whatever you want in for x and it's not going to change the bottom. You'll notice that number 3 has some new directions. This one says reduce. So now we're going to work on that other piece of fractions that we were talking about. We're going to reduce this fraction. When you're reducing, what we're doing is taking common factors and getting rid of them. Because if you had, for example, a 5 on the top and a 10 on the bottom, you could take a common factor of 5 and remove it from top and bottom, because it's like removing a 1, 5 over 5. Now this one's a bit more complicated. We've got a few things going on up here and several things going on down here. But again, we're looking for things that we can reduce with, so common factors that we could remove from the top along with the bottom. Now if you can't do it on top and bottom, you can't do it because it's got to be a 1 that you're pulling out, like 5 over 5. So in this example, when I see the 12 and the 16, I'm looking for a number that divides into 12 and 16, and I think it's going to be 4. So I'm going to pull a 4 out of this 12. If I pull a 4 from that 12, it's going to leave me with a factor of 3. If I pull a 4 from the 16, 4 goes into 16 4 times. So that is us reducing 12 over 16. Let's look at the x's. So up here I have x to the third, and down here we have x to the fourth. So it looks like I could cancel out 3, or x to the third power. So x to the third up here is going to be gone. Now on the bottom we have x to the fourth. I'm taking x to the third out, so that means I would have one of those left. So just an x. Let's look at the y's. Up top I have a y. On the bottom I have y to the third power. But up top I only have one of them, so I can only cancel 1. So I'll get rid of this one. And I've got to get rid of one of those. If I had 3 there and I get rid of one of them, I'll have 2, or y squared, left. At this point, I think I've done everything I can do. I'm going to go ahead and put some things together here and see what we got. Up top, the only thing I had left is a 3. And on the bottom, I've got a 4x y squared. And then before we say we're done, we're going to look at this and make sure we didn't miss something. If you miss something, it's no big deal. You can just do another round of reducing. You don't have to go back and start over. You can just keep going and do it again. Let's do one more. Now, this one is very different than the last one. We're still reducing, we still have a fraction, but you may notice in the last problem, everything was being multiplied. Here we've got some add and subtract. Remember, when we're reducing, what we're doing is canceling common factors. And right now, I don't have it in factored form to cancel common factors. It is so tempting to want to take this 3 and this 9 and reduce. But you cannot do that because of order of operations. This 3 is linked with this x. So in order to cancel this, I'm going to have to cancel an x plus 3 factor with another x plus 3 factor. So before we can even do anything here, we need to get this guy in factored form. Now the top doesn't have much I can do. It's just going to be x plus 3. But on the bottom, you'll notice that's a difference of squares. So if we were to factor that, we would have 3 minus x and 3 plus x. The only way to cancel is canceling common factors. So you have to have it in factored form. Now that it's in factored form, I actually see a set of common factors. They look a little funny, but x plus 3 up here is the same factor as 3 plus x. Because remember, addition, you could write it either way. And so I can cancel this x plus 3 with this 3 plus x because they match. When I do that, on the top, I've canceled everything. Now remember, if you wanted to write a number here, you could write a 1. We just typically don't do it very often because it's not that necessary, because multiplying by 1 is not going to change anything. But when everything cancels and you need something in that spot, you're going to have a 1. And then on the bottom would be 3 minus x. This is the reduced version of our original rational expression. The key to success going forward in all these rational expression kind of topics is understanding what you can cancel and what you can't. Here, we cannot cancel these x's and this 3 and the 9 because we do not have common factors yet. X plus 3 will only cancel with another x plus 3. 9 minus x squared in this form would only cancel with a 9 minus x squared. So we have to factor things and then cancel common factors.